In exercise 8.13, they want us to prove this formula, one formula here in the Gensen system, and they have given us a hint, retaining the formula from the conclusion in the premise of rules right for all and left existence. No, left for all and right existence may be necessary. Yeah, so this proof needs to be structured a bit differently than usually. I'm going to call this at the bottom here, or what we want to prove for f, just to make the proof a bit nicer. So I'm just going to call this is f. And also I think that instead of, one thing with f is that this x here is not the same as this x here, because the quantifier here covers all of them, but only affects this x because this x already is in the quantifier of this one, if that makes sense. So what I'm trying to say is that I will rewrite this x as this will be w instead of x, just to make things more clear. So then we can start. We'll have the first line. I'll just have f, and I want to show that this is admissible in the prove it in the Gensen system. Oopsie daisy. So what rule can I apply first to solve this proof, to do this proof? If we have a look at what f is here, there's actually only one thing we can do, which is apply the rule to get rid of this quantifier right here. So if we have a look at the rules that we have, the rules that we have, we want to use this rule here first. Oh, sorry, no, it's not this rule, it's this rule here, because the f is on the right side of the provability symbol. So all we have to do is make a legal substitution. So we can substitute x here for anything legal. It doesn't have to be fresh. And I think I'm going to just fade out those rules like last time. Oops, that's the wrong one. We want to fade out the rules. There we go. Yeah, so I'll substitute this for a variable that I'll call a. So I'll just be introducing variables a, b, and c. So we say that f, whoops, I am in the wrong layer. We say that this substitution here for x for a is legal. And then we use this rule here. So then we have provability proves in G, f, and the substitution. Remember, we maintain the previous formula that we have and then add the substitution form next to that. So we just keep the f and then we write e, y, p, x. Whoops, we don't have x anymore. We have a now. A, y implies for all z, and then existence w. Remember, we're using w here. And then we have p, z, w. Okay, so now we have gotten rid of this quantifier here, and we can get rid of the implication here by using the right implication rule. So we'll do that. Our aim is, of course, to get rid of this for all quantifier here, because it will be on the right side, which means that we have to introduce a fresh variable again. So, whoops, just. So we're using the right implication rule, right implication. Then we have, so we have to move this here onto the left side and this part here onto the right side. So I'll have existence y, p, a of y. That's on the left side. And then on the right side, we still have our f, and then we have for z, not x, z, is this w, and PZW. Okay, great. Now we can apply this fresh rule here to get rid of the for all quantifier here. So I need to introduce a new fresh variable. I will use b. So I'll just write on the side here that b is fresh. There we go. Oops, that's not it. So we'll use the left for all rule and get rid of this quantifier here. And we had b, so we substituted z for b, so we have b here now, w there. Okay, and here I'm going to stop and try to explain to you what the next couple steps are going to be. So remember in the hint, they said that we should retain the formulas that we get from the conclusion in the premise of rules, of those rules there. And we've so what they're trying to say is that we have to go back here and like retain what we have and then use it, keep using it later on. So here we have a p, predicate p with a and y, and whoops, here we should have had predicate p. I'm just going to rewrite that because I forgot the p. We're going to have the predicate p, but here we have b and w. Now we can't. We've already gotten a b here. We've gotten an a here, so we can't really change those. So we need to sort of get the predicate p over again, but with either a b in the first place on the left side or an a in the first place on the right side. So how can we do this? Well, we're going to have to do something with the f again, and we still have f here, as we can see. F is still there, f is still intact, I guess. So we can use that again to put in new variables in the first position by just applying the same rules over again. But what rules can we actually apply? So if we were to redo f, and for example want to have b in the first position on the left side here, then could we just use this rule over again? Well, we wouldn't be able to do it if the existence formula was on the left side, because then we'd have to introduce a fresh variable. But remember here, the a here is fresh just because it was, well, we just use a fresh formula, but we didn't have to. It just had to be legal. And so we can just use b in place for this rule, because substituting b would be legal. And then we would get pby and not pay on the left side. And then I think we could solve it. Okay, so I'll just do what I've been trying to explain here. So we just essentially start the proof over again, but just do it slightly differently. So this is going to have to be a bit longer. Oops. Okay, so we apply the same rule over again. We have existence. Oops. We have existence on the left side, and we apply that to f, but we substitute b instead of a, which means that we get the same thing on the left side. So we just get e y p a y, and then here we have f, and then existence w p b w, and now comes the substitution part. So we've substituted b for x into f, which means that we get e y p b y implies for z exists w p z w. Okay, great. So now we have this pby, which we want to move on over onto the left side, which we can do by just applying the same rule over again. So we'll do that, and I'll just write here that this substitution f x b is legal. That's legal. There we go. And now I will use the right arrow rule. So use that here, and I'll move the existence y pby over onto the left side and keep this on the right side. So we'll have this side e y p a y, then we've got the e y p b y. Oops. F ow. Distance w p. Okay, fantastic. I'm just going to get rid of the rules in the background because it's making it a bit hard to read. There we go. So here we have two almost identical well-formed formulas. We have existence y pby and existence w pbw. So is there a way that we could apply rules to solve the proof? Yes, there are. So first we want to, of course, use the rule which introduces a fresh variable. And the rule that introduces a fresh variable is the existence on the left-hand side. So we'll use existence on the left-hand side first. Okay, so existence on the left-hand side. And then we apply it to this here, and we want to introduce a fresh variable, which we can call c. C is fresh. So, you know what? I'm just going to copy this line here because it's quite long. Just there. Same thing. And then. So what we've done is we've applied this rule here to this part here, which means that we have substituted y for c, where c is fresh. So this here will instead be p, b, c. So substituted y for c here. Now we just need to put in c for w here. So then we'll apply the right existence rule onto this line, and I think I'll do the same as last time. I'll just copy it up. There we go. And so we've applied this rule to this part here. So we need to substitute the w for c. So what we end up with is p, b, c, and then we say p, b, y, y. No, sorry, not y, we had w. W, C is legal. Okay, so now we have got PBC on the left side and we have PBC on the right side. So we have two identical well-formed formulas on each side of the provability symbol, and by the axiom in the Gensen system, we have now finished the proof. So got this and this, hence we finished the proof.